Okay, this is a typical long normal distribution question where you need to read through the whole question very carefully, decipher the information slowly before you go on to do the question. Okay, because the question is very long, you need to start slowly. Okay, the number of days of gestation for a Dutch belted cow, right, is normally distributed, okay, with a mean of mu days and a standard deviation of sigma days. Alright, so from here, we go on slowly to process the information. Yes, we have 8.08% of this cattle breed has a period shorter than 278 days, right? And whereas 21.2% has a gestation period longer than 289 days. So from here, looking at this itself, you should be trying to form an equation. You should be trying to form. So based on these two facts, right? Looking at this, you should be trying to form. Oh, I have here. So is it possible for me to form something? So from here, you should be trying to form what? You should be trying to form. You should trying to form two probabilities. So the first one, probability, right? That mu. Okay, so probability. So you need to define some sort of a random variable. So here, okay, most of you are able to define a random variable. Those who didn't define, you actually get one presentation mark deducted. Okay, so you need to define. Okay, so just very informally, you need to define maybe a d as a random variable for the number of days of gestation, for number of days of gestation. Right, you can define x, you can define d, you can define g, okay, of the Dutch cow. So a lot of you didn't put the Dutch cow, you just put like gestation. So actually I didn't penalize you, but because you actually didn't read that in the later part of the question there's a second cow. Alright, so 8.08 of the cattle has so basically from here, what you should be writing probability that d is less than 278 equals to 0.0808. This is the probability that you should be finding. Alright, the next one, 21.2% has a gestation period longer than 289. So you from here, probability of d greater than 289 should be equals to 0.212. And from here straight away, basically from here, you just need to do your standard normal, and you should be able to deliver the first part. And most of you got the first part. You can basically find your mu and your sigma, and most of you got your mu to be 285 and sigma equals to 5.00. Okay, very quickly, let me just show you how the solution. So basically this is what you should have. All right, the equation should look in this form. All right, this is your second two equation. You may have it in a slightly similar form but different. So all in all, most of you are able to get to the answer, which is that mu is equals to 285 and sigma is equals to 5, and you got the first 3 marks easily. Alright, then let's go to the next part. So you remember that here actually sigma is 5, right? But because sigma is going to be used later on, the one you all should be using is this number. So actually a lot of you actually end up using 5 for the next part, and this causes you to have some error carry forward. So actually let me show you later on. Okay, the next part, we need to find a probability that the mean gestation period for 32. So here we're talking about mean, so the keyword is a mean gestation period for 32 randomly chosen Dutch belted cow is more than 287 days. So what do they mean here? We're not talking about. So some of you actually misread the question. You all go and write things like 32D. Some of you all wrote things like D1 plus D2 plus D32. So actually all these are wrong. The one they are looking here, we are looking at maybe D prime. Okay, D prime, and you should have a normal distribution of say about 285.0010. You should be using the same mean as what you have in part 1. And the sigma, a lot of you actually use the wrong sigma. You actually use 5.00. Because you use 5.00, what is this? I still give you the method mark, but I minus 1 mark overall. Okay, so this one is to be good, because if I minus all the answer marks, you all will lose half the question. Okay, so I just basically minus 1 mark overall. Okay, so it's 5.00. You should be using 17961. So a lot of you use 5.00. Okay, a lot use this a lot just use sigma equals to 5.00. So for that I just did like -1 mark overall. Okay, for overall, for accuracy, this is what I think almost half the cohort did. Okay, so the correct answer is that your d bar should be following this mean and this variance. All right, and your final answer to be equals to 0.0119. So if you actually use use sigma to be equals to 5.00, then your final answer will actually turn out to be 0.0118. All right, so for that I still gave the answer mark to you. I -1 mark overall. Okay, then state a necessary assumption for the calculation to be valid. Okay, of course the most important thing is you must state independence. You cannot just write independent, you have to write independent of each other. The cows are independent of each other. You cannot just write independent. You also cannot say that they do not affect each other. Because okay, a lot of you actually use very layman terms to describe the independence. Some of you said that, oh, they do not affect each other. Which part of the cow does not affect each other? We cannot just say they don't affect each other. We have to say things like the occurrence or the mean of the number of days, all right, for the number of days of gestation for the Dutch spotted cow does not affect the number of days of gestation for another Dutch spotted cow. Okay, so we cannot just say they don't affect each other. The definition is very loose now. So you all must really define your sentences and write down properly. Okay, the best is you write down the independence. You cannot just write down the two Dutch spotted cows are independent. Which part is independent? The mean gestation period, okay, the gestation period is independent. Alright, the number of days of gestation period is independent, not just any part of the cow. Okay, so in this question, right, it's actually already normal. So if D is normal given by the question, then D bar is basically just a linear transformation of D1, and D bar is also normal. So a lot of you actually go and use a central limit theorem, which don't have to, because that's the wrong assumption, because central limit theorem is only for samples where the distribution is unknown, okay, or binomial. But in this case, no need, right? Why no need? Because your distribution is already normal, so you don't have to use CLT. Okay, so those who use CLT, actually, I actually struck it off for you, but I told you no need to use, and I didn't minus any marks, but I just tell you that no, this time please don't use it. Okay, next one is part 2. So part 2, another type of question, basically it's like a scaling question. We need to scale your variables lah. Okay, so we have J to represent the Jersey cow. Alright, the Jersey cow, the number of days is 278, the mean standard deviation is 2.5. Then for the Dutch spotted cow, it's like what we found earlier lah. So this is now we have a second cow coming in. Okay, and then there's a scale that the Dutch spotted cow is 29 kg, and the randomly Jersey cow is 26. So this question very long. You really have to read very slowly. Find the value of A during their respective gestation period, such that there is a probability of something that's equal to 0.35, but that the amount of feed consumed by a randomly chosen pregnant Jersey cow. Right, so amount of feed consumed by a random Jersey cow. So what does it mean? It means it's not referring to it's referring to each Jersey cow has a gestation period. Every day throughout this gestation period, they eat this 29 kg or 26 kg. Alright, so what does it mean? It means that the variable you have to, okay, this is the J representing the gestation period, and each day I'm eating 26 kg, right? Exceeds half of the amount consumed by a pregnant Dutch spotted cow is less than A. Alright, this less than A, but it has to be more than 0 definitely. Alright, so this is more than 0. If you still don't know, remember we did an assignment question on this, right? So with that, alright, the answers for your answer should be A equals to 3058. You should have A equals to 3058. Okay, so provided that you actually got the parameters correct, you should be using this Alright, as your variable, 26J minus half of J, 29D. So some of you put the half wrong side, you can put the half towards 26. Basically you read the question wrongly. So do read the question correctly so you know what I mean. Okay, last one is part 3. Find a probability that throughout the respective gestation period, the difference, between the amount. So difference, what do you think? They never say who's bigger, who's smaller, right? So means what? You need to use modulus. Suggest the modulus, correct? The amount of feed consumed by 3 randomly Dutch belted cows and 4 randomly Jersey cows is more than 4,000 kg. What does it mean? This means that you really you're doing quite a bit of work. So you're actually finding maybe you take C1, you probably need to find the variable of 29, because each Dutch belted cow eat 29 kg per day, and 3 Dutch belted cows, and then a cos 2 would be something like 26 multiplied by 4 multiplied by 4 Jersey cows, right? So these are the two variables that you are finding. Right, these are the two variables, so you should be using these two to help you. Okay, then in the end, what are we finding? We are finding the probability that the difference, right? The difference, we don't know who's bigger, right? Between these two costs, all right, is more than 4,000. Right, to do it properly, first, right, your variables have to be correct. I mean, your context, your answers have to be correct. So if answers or your parameters are wrong, then we cannot even talk about solving anything lah. Okay, so very quickly, let me just check through. Okay, your answers should be you should be taking the C1 minus C2, the normal should be negative 4117, then the variance should be 80020.3237. Some of you got slightly off error. So those, for example, who use sigma equals to 5, in part 1 you have something like 79975, something like that. Okay, but you still managed to get the overall answer correct. Okay, so this is the variable that you should be finding. Alright, not any other variable. So read the question carefully. This time when you get back paper, do look at whether it coincides with what you're finding. Alright.